Okay, welcome to NTI Day 25, Trig using the Pythagorean Theorem. This is going to be pretty similar to the other video we did, except this time we don't know all three sides of our right triangle. So we're going to use the Pythagorean Theorem to find the missing side lengths on our right triangles. So the formula here is just a squared plus b squared equals c squared. And now in the Pythagorean theorem, the a is one of the legs of the triangle and the b is the other leg of the triangle. And then the c is our hypotenuse. So leg square plus leg square equals hypotenuse square. And that's what we're going to use to find any missing sides in our right triangles. So we'll start with example 1. We've got a triangle. We know the legs are 4 and 8, and we know the hypotenuse is x. So we're going to use the Pythagorean theorem to find the value of our hypotenuse. So we've got leg squared plus the other leg square equals the hypotenuse square. And we don't know the hypotenuse, so we'll just make it x. So 4 squared is 16, plus 8 squared is 64, equals x squared. I'll simplify that just by combining those values. So we get 80 equals x squared. Now we want to get the value of x, not of x squared. So we're going to have to take the square root of both sides of that. And we get x equals the square root of 80. Now, 80 is not a perfect square, but we can reduce it by seeing what perfect square divides into 80. And I know that 80 is divisible by 16 and 5. Now, both of these numbers don't have to be perfect squares, just one of them does. So 16 is a perfect square. So that means x equals, what's the square root of 16? 4. And the square root of 5 is not perfect, so it's just going to stay inside the radical there. So that is the length of our hypotenuse for radical 5. So I'm just going to write that by our triangle so we know what it is. Now we're still doing trig, even though we are doing the Pythagorean theorem. So now that we know that our hypotenuse is 4 radical 5, we can find our sine, cosine, and tangent. So sine of theta, remember, our SOHCAHTOA. Sine, opposite hypotenuse. Our theta is in the top corner for this right triangle, so opposite is going to be 8. And our hypotenuse here is 4 radical 5. And then we can simplify that as much as we can. 8 divided by 4, that's just going to be 2. So then we have 2 over radical 5. And I don't know if you remember this from our unit about radical expressions, but we are not allowed to leave a radical in the denominator. It's illegal. So in order to get rid of that radical in the denominator, you're just going to multiply by radical 5 on the bottom and on the top. So that means our sine theta is going to equal 2 radical 5 over radical 5 times radical 5, which just simplifies to be a regular 5 without the radical. So that's our sine of theta. And then we're going to find cosine of theta. So back to SOHCAHTOA, cosine, adjacent, hypotenuse. Theta in our top corner of the triangle, adjacent is going to be 4. And then hypotenuse is still 4 radical 5. So then we're going to simplify that as much as we can. 4 divided by 4, that's going to cancel out, so we'll have 1 over radical 5. And again, we can't keep a radical in the denominator because it's illegal, so we're going to have to rationalize it by multiplying by radical 5 on the top and the bottom. So that'll simplify, and our cosine of theta will be radical 5 over regular 5, because a radical times itself just cancels out the radical and becomes the number underneath. So that's our cosine of theta. And then last, we'll find our tangent of theta. So tangent, back to SOHCAHTOA, is opposite adjacent. Our opposite is 8. our adjacent is 4. So that one's a lot easier. We don't have to do any rationalizing there. And 8 over 4, that's just going to simplify to be 2. So we've got our 3 trig values, and I'm just going to write them again in this corner here so they're nice and neat. So sine theta equals 2 radical 5 over 5. Cosine theta equals radical 5 over 5. And tangent theta equals 2. So those are our answers. So we're just using the Pythagorean theorem to find our missing side. Everything else is pretty similar to what we learned on Monday. Then I'm just going to do a second example so that you have more to look from when you're doing your assignment. So example 2, we've got this right triangle here. Our theta this time is in that bottom corner, and we've got one of the legs and the hypotenuse, but we don't know the other leg. So for my first leg, I'm just going to leave it x squared because we don't know what it is, plus the other leg, 22 squared, equals the hypotenuse, 24 squared. So same setup, just using that formula for the Pythagorean theorem. And then we can simplify. So x squared plus 484 equals 576. Now I want to get that x alone, so I'm going to subtract 484 from both sides. We get x squared equals 92. 92, we're going to take the square root of that, and it's not a perfect square, so we're going to have x is equal to the square root of 92. But that's not perfect, so we're going to see if we can break it up, and I'm pretty sure the only perfect square that goes into 92 is 4, so we'll have 4 and 23. And that'll simplify more because the square root of 4 is 2. And then we'll have that radical 23 left over. So that is our missing leg length. So I'm just going to write that over here, 2 radical 23. And then we'll use that information again to find our sine, cosine, and tangent trig functions. So I'm just going to block this off so we have a little room. Sine theta. Our theta is down here in the bottom, so opposite is that side we just found. So 2 radical 23 over hypotenuse, which is 24. So this is nice because we don't have to rationalize if the radical is in the numerator. We just have to simplify. And 2 over 24 can simplify to be 1 over 12. So we'll end up with radical 23 over 12. And there's an invisible 1 in front of the radical there, but you don't have to write that if you don't want to. And then we'll do cosine theta. And here's our theta. Adjacent is going to be that 22 right next to it. And our hypotenuse is still 24. So 22 over 24, that's nice. And we can simplify that to be 11 over 12. And then we'll find our tangent of theta. So opposite, which is our 2 radical 23 over adjacent, which is 22. And that's not so bad, we just need to simplify it. So 2 over 22 will simplify to 1 over 11, and we still have that radical 23 up there. So there's our sine, cosine, and tangent for example 2. I don't think I've got anything else to say on this topic, but let me know if you have any questions. Again, it's pretty similar to what we did on Monday, except this time we have to find our third side for our right triangles. I'll be posting this video along with another Google form, just like we did last time, so you can ask any questions that you have in there, and I'll return the feedback to you. You can also email me, and remember to be sending in your work so that I know you're doing it, and that if you have any questions, you can get the help that you need. I hope you're having a great day, and again, please email me. I miss you all, and that's all I got. Okay, bye.